Question 1. Which term of AP 72, 70, 68, 66 is 40? We have four options: A 16, C 18, B 17 and D 20. We have A is equal to 72 and D is equal to minus 2. When we subtract from 70 to 72, that is term 2 from term 1, we get difference as minus 2. Same way like 66 minus of 68, we get minus 2. So let nth term be 40. We take term formula, that is Tn is equal to A plus of n minus 1 D. We substitute this value A, D and the nth term, we get as 40 equal to A as 72 plus of n minus 1, D as minus 2. We calculate this, we solve this for n, we get n is equal to 17, which is our option B. Therefore, option B is a correct answer. Question 2. If for a sequence Tn, Sn is equal to 3 into 4 raised to n minus of 1, then term Tn is equal to, we have four options. We have Sn is equal to 3, 4 raised to n minus of 1. For n minus of 1, that is S of n minus 1, we have 3, 4 raised to n minus 1, 1. We know that for Tn is equal to Sn minus of Sn minus of 1. We substitute the value of Sn and Sn minus 1 in this. We get 3, 4 raised to n minus of 1 minus of 3 into 4 raised to n minus 1 minus of 1. We solve this, we get as 9 into 4 raised to n minus of 1. We get 4 raised to n minus of 1, which is our option D. Therefore, option D is a correct answer. Question 3. The 15th term of an AP 21, 16, 11, 6. We have four options, that is A minus 25, B minus 29, C minus 49 and D minus 39. We have A is equal to 21, D is equal to 16 minus of 21, which is equal to 5, where we solve for 11 minus of 16 also, we get 5. Therefore, the difference between every term is 5. We have term formula, that is Tn A plus n minus of 1 D. We're going to substitute the value of A, D and n term, that is 15, where n is equal to 15. So therefore 21 plus of 15 minus of 1 minus of 5. 16 minus 21 gives us minus 5. Please note that 16 minus 21 is minus 5. Therefore the difference is minus 5. We solve this, we get as minus 49, which is our option C. Therefore option C is a correct answer. Question 4. If for an AP S of 16 is equal to 784, A is equal to 4, then D is equal to, we have four options, A 5, B 6, C 7 and D 8. We have Sn is equal to n by 2, 2a plus of n minus 1 D, which is sum of terms. Therefore, we substitute the values, that is S of 16 at for A is equal to 4. So for S of 16 by 2, we have A value, that is 4 plus of 16 minus of 1 D. We substitute the value of 16 as 16, that is 784. We solve this, we get 8 plus of 15D. Further, we get 15D is equal to 90, which is D is equal to 6, which is our options B. Option B is the correct answer. Question 5. The fourth term of an AP is 4. Then the sum of the first 7 term is. We have 4 options: A4, B28, C16 and D40. For the fourth term, that is T4, we get as A plus of 4 minus of 1D, which is equal to A plus of 3D for T4, which is equal to 4. That is the fourth term is equal to 4. And for the seventh, sum of the seventh term, that is S7, 7 by 2, 2A plus of 7 minus 1D, which is equal to 7 by 2, 2A plus of 6D. We take 2 as common, we get 7 by 2, A plus of 3D, left with 7, A plus 3D, which we say that A plus 3D is nothing but the fourth term, that is equal to 4. So therefore we substitute 7 into T4. The value of T4 is 4, which is equal to 28, which is our option B. Therefore option B is the correct answer. Question 6. Sum of the fifth terms of an AP is 1/4 of the sum of the next 5 terms. If the first term is equal to 2, then common difference of the AP is, we have 4 options: A6, B minus 6, C3 and D2. So sum of the first fifth term is equal to 1 by 4 Therefore, the condition given as AP, that is sum of the first fifth term, is 1/4 of the sum of the next 5 terms. So the condition, we can write it as 1 by 4th s of 10 minus of s of 5. We get this as 5 of s of 5. We solve this as 1 by 4 s raised to 10 s raised to 5, that is 1 by 4th s raised to 10 minus of 1 by 4th s raised to 5. We take s raised to 5 on the left hand side, we get s raised to 5 plus of 1 by 4 s raised to 5, which is equal to 1 by 4 s raised to 10. We solve this, we get as 5 by 4 s raised to 5 is equal to 1 by 4 s raised to s of 10. So we get 5 s of 5 is equal to s of 10. So we solve this, we get 5 into 5 by 2, 2 into 2 plus of 4d equal to 10 by 2, 2 into 2 plus of 9d. We get this as d, which is equal to minus 6. Therefore our option B is the correct answer. Question 7. If 1 plus 6 plus 11 plus 16, 11, which turns to plus of x, is equal to 148, find x. We have 4 options: A 24, B 36, C 42 and D 46. So the term of a given sequence are in AP with A is equal to 1, D is equal to 5 and Sn is equal to 148. So we solve for sum of the terms, that is n by 2, 2a plus n minus 1 d, which is equal to 148. We solve this for n, we get n is equal to 8. Therefore now let the x term, that is x, be nth term. Therefore x is equal to a plus of n minus 1 d. We substitute the value of a and d and n, we get as a1 and as 8 minus of 1, d as 5. We solve this, we get x is equal to 36. Therefore B is the correct answer. Question 8. If the p, q and the r term of the arithmetic sequence are a, b, c respectively, then the value of a bracket q minus r plus b bracket r minus p plus c bracket p minus q is equal to a1, b minus 1, c0, d half. Suppose the first term and the common difference of an AP are A and the common difference B, D respectively. Now the P term is equal to A plus of P minus 1 D, which is equal to A. For the Q term, A plus of Q minus 1 D, which is equal to B, and the R term, A plus of R minus 1 D, which is equal to C. Let this be equation number 1, this be equation number 2, this be equation number 3. So for the given equation that we have A of Q minus R plus of B of R minus P plus of C P minus Q is equal to A bracket of B minus C D plus B C minus A upon D plus C A minus of B upon D. We take D as common, we get 1 by D is equal to AB minus of AC plus of BC minus of AB plus of CA minus of BC. If we see, all the terms get cancelled, that is AB, AB, BC, BC and AC and CA. Therefore, we left by 1 by D into 0, which is equal to 0, which is our option C. Therefore, option C is a correct answer. Question 9. If the first term of an AP be 10, last term is 50, and the sum of all term is 300, then the number of terms are, we have 4 options, A5, B8, C10 and D15. So given the first term, that is A is equal to 10, the last term is equal to 50 and the sum, that is S, is equal to 300. So we have formula for that. S is equal to n by 2 A plus L. We substitute the value of all the terms and solve for n, that is 300 equal to n by 2 10 plus 50, which is n is equal to, we get as 10. Therefore option C is a correct answer. Question 10. The solution of equation x plus 1 plus of x plus 4 plus of x plus 7 plus of x plus 28 is equal to 155 is, we have 4 options, A1, B2, C3 and D4. So we have x plus 1 plus of x plus 4 plus of, continue to x plus of x plus 28, which is equal to 155. Let the n be the number of terms in an AP. Therefore LHS then we get as x plus of 28, which is equal to x plus of 1 plus of n minus 1 3, which we solve for n, we get n is equal to 10. Therefore x plus of 1 plus x plus of 4 plus of continuity of x plus 28, which is equal to 155. So we solve for n, that is 10 by 2 x plus n plus of x plus 28, which is equal to 155. So solving this, we get x is equal to 1. which is our option A. Therefore, option A is the correct answer. Question 11. The number of terms of AP 3, 7, 11, 15 to be taken so that the sum is 406. S, we have four options: A5, B10, C21 and D14. We have formula for sum, that is sum n upon 2, 2a plus of n minus 1 d. We substitute the value. We know that a, that is the first term, is 3, and the difference d is 7 minus of 3 is 4, that is 11 minus of 7, that is 4. So the difference is 4. So for s we have 406. So 406 is equal to n by 2. This we get as 3 plus n minus of 1, 4. We solve this, we take 2 over there, we get as 812 n by 6 plus of 4n minus of 4, which is 812 2n plus of 4n square. We take 2 as common, we get as 406 2n square of n. Now if we see 2n square plus of n minus 406, it's a quadratic equation, so we solve for n. We take we solve this, we get as minus 1 plus of under root 3249 upon 4, which is the root of 3249 is 57 upon 4. So taking n as positive, we take as n as positive, that is n is equal to 1 plus of 57 upon 4, which we get as 56 upon 4, which is 40, which is our option D. Therefore, option D is the correct answer. Question 12. If A1, A2 be the two arithmetic mean between 1 by 3 and 1 by 24, then the values are, we have four options, that is A 7 by 72, 5 by 36, B 17 by 72, 5 by 36, C 17 by 36, 5 by 72, and D 5 by 72, 17 by 72. Here 1 by 3 and the two arithmetic mean, that is A1 and A2, 124, will be in AP. So then A1 minus of 1 by 3 is equal to 1 by 24 minus of A2. Therefore, A1 plus of A2 is equal to 3 by 8. Let this be equation number 1. Now A1 is arithmetic mean of 1 by 3 and A2 therefore 2A1 is equal to 1 by 3 plus of A2. We solve this, we get 2A1 minus of A2, which is equal to 1 by 3. Let this be equation number 2. From 1 and 2 we get A1 is equal to 17 by 72 and A2 by 5 by 36. We solve 1 and 2, we get A1 as 17 by 72 and A2 is 5 by 36. Therefore, our option B, is a correct answer. Question 13. Three numbers are in AP whose sum is 33 and the product is 792. Then the smallest number from this number is, we have four options: A4, B8, C11 and D14. Suppose that the three numbers are A plus D, A and A minus D. Therefore, for the first condition, that is A plus D plus of A plus of A minus D is equal to 33. That is sum is equal to 33. Therefore, we get A is equal to 11. And for the product, that is the second condition, we get as A plus of D, A minus of D, which is equal to 792. We substitute the value of A, we get as 11, 121 minus of D square is equal to 792, which is D we get as 7. Therefore, the required number are, We substitute the value of a and 7 in the terms, so we get 4, 11 and 18. So the smallest number is 4, therefore option A is the correct answer. Question 14. How many terms of the GP, that is 13927, have to be taken to get the sum equal to 3280? Sorry, that is 3280. Therefore we have 4 options: A 5, B 8, C 7, D 6. We have A is equal to 1 and R is equal to 3. So for the sum of first n term of a GP, we have Sn is equal to A of R n raised to n minus of 1 upon R minus 1. Therefore we substitute the value, we get 3280, which is equal to 3 raised to n minus of 1 upon 2. We solve this, we get 6561 is equal to 3 raised to n minus of 1. We shift minus 1 over left hand side, we get 6562 raised to 3 raised to n. We can write this as 3 raised to 8, which is equal to 3 raised to n. Therefore we compare this, we get n is equal to 8, which is our option B. Therefore option B is a correct answer. Question 15. The sum of n terms of 2 plus 22 plus 222 plus is, we have 4 options. We have Sn is equal to 2 plus 22 plus of 222 plus of n terms. Therefore A, we take 2 as common, we get 1 plus 1, 11, 1, 1, 1 plus n terms. We can write this as 2 by 9 of fine adjustment, that is 10 minus of 1 plus of 100 minus of 1 plus of 1000 minus of 1, which tends to n term. We can this write it as 2 upon 9, 10 of 10 raised to n minus of 1, 10 minus of 1 minus of n. That is 2 upon 9, 10 upon 9, 10 raised to n minus of 1 minus of n. We can write this as, we take 9 outside, we get 2 upon 81, 10 raised to n minus of 1 minus of 9 n, which is our option B. Therefore option B is the correct answer. Question 16. If the first sum of a GP is 2 and the sum to infinity is 6, then R is equal to, we have 4 options: A 1 by 3, B 2 by 3, C 3 by 2 and D 4 by 3. We have first term, that is A is equal to 2, and for sum of first term of a GP for infinity, that is S infinity is equal to 6. So we know the formula for infinity is equal to A upon 1 minus R, where R modulus is less than 1. Therefore we substitute the value, that is for S infinity we have 6, 2 upon 1 minus R, we get 1 minus of R is equal to 1 by 3. We solve this, we get as R is equal to 1 minus or 1 by R, which is equal to 2 by 3, which is our option B. Therefore option B is the correct answer. Question 17. The sum of first 8th term of GP is 82 times of the sum of the first 4 terms. The common ratio of GP is A4, B5, C3 and D2. Therefore we write S8 is equal to 82 of S4. Let the GP be A plus A of R plus of A into R square plus of, then we can write S of 8 as A 1 minus R raised to 8 upon 1 minus R equal to 82 a of 1 minus r raised to 4 upon 1 minus r. We solve this, we get as 1 minus r 4 raised to 4, 1 plus r raised to 4, which is equal to 82, bracket 1 minus r raised to 4. We solve this, we get r is equal to 3. Therefore, option C is the correct answer. Question 18. For a GP 3, 12, 48, 192, SN is equal to, we have 4 options. We have A is equal to 3 and R is equal to 12 by 3, which is equal to 4, which is greater than 1. Therefore, for SN we have R is to N minus of 1 upon R minus of 1. We substitute the value, we get 3, 4 raised to N minus of 1, 4 minus of 1, which is equal to 4 raised to N minus of 1, which is our option C. Therefore, option C is the correct answer. Question 19. If for a GP R is equal to 2, S of 8 is equal to 510, then T of 3 is equal to, we have 4 options, A8, B4, C16 and D12. We have S of N, that is A into R raised to N minus of 1 upon R minus of 1, where R is equal to 2. Therefore, we have N is equal to 8. We substitute the value, we get 2 minus of 1, which is equal to A of 2 raised to 8 minus of 1, which is equal to S of 8 is equal to 510, A 2 raised to 8 minus of 1. We solve this, we get A is equal to 2. Therefore, T of 3 is equal to 2 of 2, 2 into 2 raised to 3 minus of 1, which is equal to 2 into 2 raised to 2, which is 2 into 4, which we get as 8, which is our option A. Therefore, option A is the correct answer. Question 20. 3 numbers are in GP whose sum is 70. If extremes be each multiple by 4 and the means by 5, they will be in AP. Find the numbers. We have 4 options, which is in AP. So let the numbers be A, AR and AR square. So sum is equal to 70. We take A as common, we get 1 plus R square is equal to 70. This is the first condition where sum is equal to 70. So A plus of AR plus of AR square, we get this as, we take A common, which is equal to 70. So it is given that 4A, 5AR, 4AR square are in AP. That is, the multiple by 4 of each extreme terms we get as AP. So for solve this, we get as 25AR equal to 4A plus of 4AR square. Therefore, we get R is equal to 2 or R is equal to half. Substituting the value of R, A as 10 and A as equal to 40. So the numbers are 10, 20, 40 or 40, 20, 10, which is our option A. Therefore, option A is the correct answer. Question 21. The first term of GP is the sum of third and the fifth term is 90. Find the common ratio of GP. We have 4 options, that is in plus and minus, that is A plus minus 4, B plus minus 5, C plus minus 3 and D plus minus 6. Let R be the common ratio of GP, where we have T3 is equal to R square and for T5 we get R raised to 4. So the sum of both, that is T3 plus of T5 is equal to 90. We substitute the value of T3 and T5, we get as R square plus R raised to 4 equal to 90. We solve this, we get as R square is equal to 90. We take the root, we get as, so this is 9, R square is equal to 9. We get as plus minus of 3. Therefore, R is equal to plus minus 3, which is our option C. Therefore, option C is the correct answer. Question 21. If the product of the three consecutive term of GP is 216 and the sum of the product of pairwise is 156, then numbers will be, we have options in sequence, that is series, that is A139, B2618, 3C 3927 and D248. The numbers are A upon R, A and A into R. Under condition we get A by R into A R equal to 216. The way we solve for A, we get as A is equal to 6. The sum of the product pairwise will be given as A by R into A plus A by R into AR plus A into AR, which is equal to 156. We get R is equal to 3. Hence the numbers are 2, 6 and 18, which is our option B. Therefore, option B is the correct answer. Question 23. The arithmetic mean between the two numbers is 32 and the harmonic mean is 8. Thus, find the geometric mean. Therefore, we have four options: A16, B4, C256 and D64. So the arithmetic mean can be written as A plus B upon 2, that is equal to 32, and the harmonic mean can be written as 2AB upon A plus B, which is equal to 8. Therefore, the product of this both we get as A plus B upon 2 into 2AB upon A plus B, which is equal to 32 into 8. We solve for AB, we get AB is equal to 256. Therefore, the geometric mean is equal to under root of AB. Therefore, we substitute the value of AB, that is 256, we get as 60. Therefore, our option A is the correct answer. Question 24. If 7th term of harmonic progression is 1 by 10 and the 12th term is 1 by 25, then the 28th term is, we have four options: A 1 by 37, B 1 by 41, C 1 by 45 and B 1 by 49. Considering the corresponding AP, that is A plus 6D is equal to 10 and A plus 11D is equal to 25. So we solve this, we get D is equal to 3 and A is equal to minus 8. So for T20 is equal to A plus of 19D, which is equal to minus 8 plus of 57, which is equal to 49. Therefore, the hence 20th term of the corresponding HP is 1 by 49, which is our option B. Therefore, option B is the correct answer. Question 25. If R3 plus 5R plus 7R square plus tends to infinity is 44 by 9, then R is equal to, we have four options: A 17 by 11, B 1 by 4, C 11 by 17 and D 4. Here A is equal to 3 and R is equal to R and D is equal to 2. Therefore, for infinity, that is sum of infinity, we have 1 A upon 1 minus R plus of dr upon 1 minus R square, which is modulus less than 1 if R modulus is less than 1. So we solve this, we get as infinity 3 by 1 minus r plus of 2r upon 1 minus r the whole square. We solve this, we get 44 by 9, which is equal to 3 minus r upon 1 minus r the whole square. We solve this, we get 44 r square minus 79 r plus of 17, which is equal to 0. We solve this, we get r is equal to 1 by 4 or 17 by 11. But we see that r is not equal to 17 by 11. Therefore, we see the condition, that is r modulus should be less than 1. So the 17 by 11 answer gets off. We left with r is equal to 1 by 4, which is our option B. Therefore, option B is the correct answer. Question 26. If x modulus less than 1, then 1 plus 3x plus 5x square plus 7x cube plus tends up to infinity is equal to, we have 4 options. Therefore, we have, let s is equal to 1 plus 3x plus of 5x square plus of 7x cube plus, that is to infinity. For we multiply x, that is we get x plus 3x square plus of 5x cube plus of infinity. So s minus of xs is equal to 1 plus 2x plus of 2x square plus of 2x cube plus to infinity. For we take s as common, we get 1 minus of x plus 1 plus of 2x plus of 2x square plus of 2x cube to infinity. Therefore, we get s, we take 1 minus x into right hand side, we get as 1 plus 2x upon 1 minus x. We solve this, we get as 1 minus x plus of 2x upon 1 minus x. We get this as 1 plus x upon 1 minus x the whole square. Therefore s is equal to 1 plus x upon 1 minus x the whole square, which is our option A. Therefore option A is the correct answer. Question 27. Summation of r equal to n to r equal to 1 to n to r plus 5 equal to, we have 4 options. So we have summation of r is equal to 1 to n to r plus of 5. We can take summation inside the bracket, we get 2 r is equal to 1 to n r plus of summation of r equal to 1 to n 5. We solve this, we for r we get as 2 n plus 1 2 plus of 5n. We solve this, we get as n plus of 6, which is our option D. Therefore option D is the correct answer. Question 28. Bracket 2 raised to 2 minus of 1 raised to 2 plus bracket 4 raised to 2 minus of 3 raised to 2 plus bracket 6 raised to 2 minus of 5 raised to 2 plus is 2 equal to, therefore we have 4 options. A, n into 3n plus 1, B, n square into 2n plus 1, C, n square 3n plus 1, D, n into 2n plus 1. So we have 2 square minus of 1 square plus of 4 square minus of 3 square plus of 6 square minus of 5 square plus of, we separate the even numbers and the odd numbers. We get 2 raised to 2 plus 4 raised to 2 plus of 6 raised to 2 plus minus of 1 raised to 2 plus of 3 raised to 2 plus 5 raised to 2. So we can write this as summation of r is equal to 1 upon n 2r the whole square minus of r is equal to 1 2n 2r minus of 1 the whole square. We solve this, we get as r is equal to 1 and 4r summation of r is equal to 1 and 1. If we solve this, we can write 4, we can take 4 as common, and we get as 4 n plus of 1 upon 2 minus of n. Therefore we solve this, we get as n of 2n plus of 1, which is our option D. Therefore option D is the correct answer. Question 29. If 1 square plus 2 square plus 3 square plus n square is equal to 1015, then the value of n is. We can write this sequence in as 1 of 1 plus of n, 2n plus of n upon 6, which is equal to 1015. Therefore we solve this, we get n of n plus n 1, 2n plus of 1, which is equal to 6090. We can write n plus of n, 2n plus of n. We can make a fine adjustment in this, and we can write this as 14 into 15 into 29. So we take n is equal to 14, n plus 1 is equal to 15, and 2n plus n is equal to 29. We solve this, we get this as n is equal to 14, and also this as equal to n is equal to 14. Therefore our option B is the correct answer. Question 30. The sum of n terms of the following series is 1 into 2, 1.2 plus 2.3 plus 3.4 plus 4.5 plus shall be. We have 4 options. The first factors of terms of given series can be written as 1, 2, 3, 4 tends to n. And the second factor, this is the first factor, and the second factor can be written as 2, 3, 4 tends to n plus of 1. So n term of given series can be written as n into n plus of 1 equal to n square plus of n. Therefore we can write this as summation of n square plus summation of n, that is 1 by 6 n of 1 plus n 2n plus of 1 plus of n by 2 n plus 1. Further solving this, we get as 1 by 6 n of n plus 1, 2n plus 1 plus 3. We can write this as 1 by 3 n into n plus 1 n plus of 2, which is our option B. Therefore option B is the correct answer.